Hi guys, today we are going to discuss about transistor. There are two basic types of transistor, bipolar junction transistor and the other one is MOSFET. So we will discuss the MOSFET in maybe some other videos. In this video we are going to discuss everything about bipolar junction transistor and its types. In transistor we are having many things. So first of all we will try to explain the working of transistor. Then we can try to find out about the n-type and p-type doping, how these doping could be formed, then p-n junction depletion region. I will also use a LDR example to explain you exactly how this transistor could be working. And finally we will discuss the modes of transistor. So let's begin. Transistor is having basically three terminals: emitter, base and collector. As we can see in the diagram, one is collector, one leg is for collector, one leg is for base and one leg is for emitter. The main use of transistor is switching and controlling electric power and signal. Why transistor is so important? The reason is we are going to use millions of transistor in the manufacturing of IC microcontrollers. So this is very important component of electronics. If you have the good understanding of this transistor, only then I can explain you in later videos how we can use the transistor in PCB designing, how we can use the transistor while we are going to control this transistor with the help of programming to the microcontroller. So the understanding of transistor is very important for having a deep understanding or being a good expert of PCB designer. Basically in BJT we are having two types, PNP and NPN. These transistors made up of semiconductors, and semiconductors are fall between conductors and insulator. Silicon is one of the best semiconductor as it has 14 electrons in it. 4 electrons are in its valence shell, and at this time silicon want to make a covalent bond with other silicon atoms, so it need 4 more electrons. Then how it will do? Then this doping comes at this point. What is doping basically? Doping is just a technique to change the number of electrons and holes in a material, and we are going to use phosphorus and aluminum in this tutorial to explain you for the formation of n-type and p-type materials. Here you can see very clearly one silicon atom is making covalent bond with another silicon atom, and they are having now 8 electrons in their outermost shell, and each one have same like this. Now at this point we are going to add phosphorus in these silicon atoms, or we are going to dope them in silicon. Here you have to understand that phosphorus have 5 electrons in its valence shell, and here silicon need only 4. Where the 5th electron will go? This 5th electron will be freely moving in the atom, and as we are not going to add only one atom, we are going to add maybe millions of atoms of phosphorus in silicon. So each phosphorus is having one electron is freely moving. And finally, when we are going to find at the final of the doping of n-type, we are going to have a big amount of electrons which are going to freely moving in this n-type doping. That's the reason that is highly negatively charged. And this is the p-type doping. In p-type doping, we add aluminum, as aluminum have 3 electrons in its outermost shell. Here we can see very clearly 4 electrons are here for silicon, and 3 electrons, maybe we can say 1, 2, and these 3 electrons for aluminum, they are combining with this silicon. and silicon is less with one electron, and that becomes a hole here. That's why in p-type doping, if each aluminum atom will bring one hole for with itself, and millions of aluminum atoms will make millions of holes here, and we don't have much electrons to fill these holes. So in this p-type doping, that is highly positively charged. Now we understood exactly what is p-type and n-type doping and how they form. In next part, here we can see how the p-n junction is going to form. We are going to sit together or bring together this p-type and n-type material. Let's see what happens. The electrons of n-type, few electrons of n-type are going to fill these holes of p-type, and they come up with a depletion region or barrier, and this is called p-n junction. This is the way how the p-n junction is formed. So first of all, we have to make p-type, n-type, and then we have to bring them together, and then depletion region is formed. Now at this point, this depletion region will never allow to pass these electrons and to fill these holes at any cost, unless or until when we provide some external power or battery, then this thing could happen, or then this depletion region could be break. Otherwise, this is the final thing of formation of p-n junction or depletion region. From this p-n junction, we are going to make NPN transistor and PNP transistor. As from the words we can see, we are using three types: N-type, P-type, and again N-type. In this NPN transistor, we are having two junctions. First is N and P junction, and second one is P and N junction, as we can see here. And as already we discussed how this depletion region is formed, so in this NPN transistor we are having two depletion regions. First one we can call it emitter, second one we can call it base, and third one we can call it collector. Now we will understand in next slide how this NPN transistor is going to work for us, why it is so important. That's the same thing which I explained here. And you have to understand this thing. This base is the controlling point of this transistor, and then the transistor is going to control the whole PCB or circuit where we will use it. If we will give a little amount of current, then only the current could flow from collector to emitter. And how it will happen? Just imagine we are going to give a small power here. Only then these electrons will be able to break this depletion region, and the amount of power we need to give here should be more than 0.7 volts. Less than 0.7 volt, this junction will not break. More than 0.7 volt at p-type and connecting to the emitter side, then we can break this depletion region, and the current could flow from emitter to the base, and in this way. One thing keep in your head, here we are going to discuss only non-conventional current. We are not going to discuss here conventional current, because the non-conventional current can explain us how the transistor is going to work for us. That is the most easiest way for us to explain here. Let's go to the next part. This is the main thing which you have to understand, and you have to give a complete focus to this diagram. And I try to make same as like we have the original shape of the transistor in our daily life, or in electrical there's an electrical symbol, and I try to make the same thing. It is not physically like this, but I try to explain in a very easy way. That's why I make this thing little bit lower. As you can see here, the basis part is little bit lower. What will happen? I am going to connect a battery here between p-type, and the negative terminal of the battery is connected to the n-type, to the emitter side. And just forget this battery first of all. What will happen? When I will connect a battery which can provide to this point more than 0.7 volt, then these electrons will be able to break this junction or depletion region, and these electrons will fill the holes at base here. In this way, the electron flow in this part will be able to be, it will be possible, and this is the forward bias junction. Now only this part is working, this part is not working, and this battery is not connected till now. As this is NPN transistor, and we can imagine, and we will connect the battery as we want to make this junction as a reverse bias. That's why we connect battery here, the positive terminal to the N type, which is the negatively charged, and that is collector, and the other negative terminal of the battery to the emitter type. What will happen? First of all, you have to understand, we are going to connect two negative terminals here to the emitter side. One is this one from this battery. This thing will inform us that we are having a big amount of electrons here. Now what will happen? As we have connected the positive terminal of battery to this N type, so this positivity of this battery will attract these electrons in N type towards this part. So there is already a junction which is the reverse bias, and this distance will become more, and it will be a big reverse bias, we can say, because we are having a big distance from this part and from this part, because it is morely tightly going backward to this terminal. Now what will happen? As I already told you that this area is having a big amount of electrons, and this thing is already moving. We don't have much holes at base to fill them. So these electrons will try to go and try to jump this barrier, and try to, maybe they want to flow in this direction as I am moving the mouse. What will happen? This is forward bias, that is okay. So a big amount of electrons are here. So few electrons which are having some more power, they will be able to cross the barrier, and they can jump, and they can maybe fill these holes, and they can pass through the barrier, and they can make a current flow from this way. That's why even in reverse bias we are having some amount of current or flow of charge in this direction from collector to emitter side. Now this thing is the active mode, in which it will I will also discuss this thing in the later part, but I just want to show you that this is the active mode, because in which we are having one junction is forward bias, one junction is reverse bias, that is the active mode. Now you have the complete understanding how we can use this transistor in a very proper way, just giving some volts, one part is working, one part is a little bit working, how we can connect the batteries. This thing you can have a good idea in later part when I will explain with the example. The same thing which I was explained before is applied to this transistor. This battery, just take it as LDR. This circuit will work only in daytime, because I am not giving you the values, just giving a good idea how you can use a transistor in any circuit. This battery is going to give power to this one, and in daytime, in night this thing will not work, but in daytime what will happen? This light dependent resistor will get, its resistivity will decrease, and it will allow the current pass through it, and it will go to the base. At night this will be having a very high resistor, and it will not allow current to pass from it, and this thing will happen only in daytime. In night this LED will not blow. In daytime this LDR will allow to flow the current from here and go to the base, and then this collector to emitter terminals will be in working, and then the current will flow from the LED and it will glow. This is the most easiest and most simplest circuit which I could explain, because in later videos I am going to explain you that giving the value of this giving the value of this resistors, battery, LDR and everything. So you have to understand this thing in clear way, how the transistor is working as I explained you here. And this is the NPN transistor. Don't confuse this thing that here in normal life I am having collector here and emitter here and this arrow is downward direction. Why? Because here I told you that I am using non-conventional current because I want to teach you that the electrons should flow, holes don't flow. But in real life, to be easy in mathematics, we use conventional current which will always flow from positive to negative terminal. We consider it. That's why this direction is downward and we are moving from collector to emitter. In this diagram, you can also say this positive terminal is going here and it will flow like this. Yes, obviously, in calculations, we will go like this. But in understanding, we are going like this. So don't mix these two things. That's why we are having the electrons are flowing from emitter to collector. Right? And these are the three operating modes. The junction, the diodes, or the junction will always between collector to base and base to emitter. There is no junction between collector to emitter. Keep this thing in head. In cutoff mode, these both junctions will be reverse bias. In saturation mode, both will be forward bias. And in active mode, this B to E will be forward bias and C to B, collector to base, will be reverse bias. And in this case, transistor operates as a current amplifier because it will at output it will give a big amount of current. And we will discuss everything like by giving values and how we can use it in real life. Real life mean by giving with the help of some sensors, and how we can control these transistors with microcontrollers by giving programming. In later videos we will discuss everything, and that's the whole thing which you have to understand. If you like my channel, if you like my video, you can subscribe, and if you want that I should make some videos on some more different topics which will be helpful for us for the PCB learning, then you can tell me, we can make a video for that. Thank you so much.